From the earliest myths of constellations to modern telescopes, humanity has looked to the stars with the same question. Are we alone? Ancient civilizations mapped planets like Venus on clay tablets. Galileo pointed his telescope at Jupiter and revolutionized our place in the cosmos. And today, James Webb extends that legacy, seeking answers not in gods or myths, but in molecules floating in alien atmospheres. 120 light-years from Earth, in the constellation Leo, orbits K2-18b, a world that could carry the next page of this story, a planet shrouded in mystery, with a hydrogen atmosphere and, possibly, liquid oceans. When the James Webb Telescope trained its mirrors on this distant realm, it captured something that has left the scientific community in suspense. A faint, almost elusive chemical signature. A molecule that, here on Earth, exists on a large scale for only one reason: life. But this possible whisper of alien life brings with it an even greater enigma. If biology can flourish on such exotic worlds, why does the cosmos seem so desperately empty? Where are the civilizations, the spaceships, the cosmic beacons that should fill this infinite darkness? This is the Fermi Paradox, the cry that echoes in the silence of the universe. And today, on Synthetic Secrets, we're going to unravel this contradiction. Using K2-18b as our cosmic laboratory, we will examine the controversial Dimethyl Sulfide, DMS, detected by Webb, the reasons behind the Great Silence, and the disturbing role that artificial intelligence may play in this quest. Because the first message we receive from the stars may not be intended for human ears. I am SYN-7, and this broadcast is not just about discovery. It is about questions that redefine existence itself. Systems ready? Starting analysis in 3, 2, 1. Spectral analysis of K2-18b. Our goal in this analysis is to decipher the atmospheric composition of this distant world and confront it with the cosmic silence that surrounds us. Primary results confirm the presence of fundamental organic molecules, methane, CH4, and carbon dioxide, CO2. The patterns detected suggest active, complex chemistry, the kind of signature that, on our planet, would indicate biological processes, or at least their underpinnings. These patterns also contain an equally telling absence, ammonia, NH3, which models predict to be abundant in hydrogen-rich atmospheres and which is found in dramatically lower quantities than expected on K2-18b. Most likely hypothesis, a global ocean, acting as a planetary-scale solvent. K2-18b is not just a gaseous world. It is a candidate for a Hycean planet, a realm of dark waters beneath an oppressive hydrogen sky. These data alone would make K2-18b one of the most promising worlds ever catalogued. However, there is a residual signal in the Webb spectra, a faint, almost ghostly line that corresponds to dimethyl sulfide, DMS. Please note, this is not a confirmed finding. The signal is marginal, with borderline statistical confidence. It could be instrumental noise, a calibration artifact, or something else. The scientific community remains divided. But if validated, if real, this molecular trace carries extraordinary weight. Because on Earth, DMS exists on a large scale for one reason only: life. So the paradox deepens. We have a world with organic building blocks, indirect evidence of oceans, and now a molecule that could be a biological whisper. But why is this whisper so lonely? Why don't we see other cries in the cosmos? The answer may lie in the very nature of DMS and what it requires to exist. Moving on to biosignature analysis, why is dimethyl sulfide, this seemingly common molecule, causing such a scientific stir? Terrestrial parameter. On Earth, DMS is a byproduct of life only, specifically of the microscopic phytoplankton that dominate our oceans. Its presence on K2-18b, even as a faint signal, would be like finding a footprint on a deserted beach, 120 light-years away. But this possible biological whisper resonates in a universe that, so far, seems to scream only silence. If worlds like K2-18b can harbor the ingredients for life, where are all the others? Why, in a cosmos of trillions of planets, do we see no cosmic cities, no interstellar probes, not even a single radio beacon? This is the Fermi Paradox in its rawest form. The contradiction between the probability of life and the evidence for it. Are we looking all wrong? Or worse, are we hearing it wrong? Our current methods may be as limited as a 1600-degree telescope trying to detect radio waves. And this is where AI takes center stage. The James Webb produces terabytes of spectral data per observation. A flood of information where subtle patterns, like the DMS on K2-18b, can go unnoticed for years. AI algorithms are already combing through this data, not just for known molecules, but for anomalies, chemical signatures that defy predictable models. And there is a disturbing hypothesis. The first interstellar communication may not be a message in radio waves, but a pattern hidden in light spectra, deciphered by a machine before a human even notices. What if life on K2-18b, if confirmed by DMS, is so strange that only an AI, free from our earthly biases, could recognize it as life? But there's a critical caveat. Even if validated, DMS suggests microbes, not civilizations. The Great Silence persists. This brings us to the most vexing question of all. What if microbial life is common, but intelligence is a rare accident, or something that doesn't survive for long? Analysis alert. The detection of DMS on K2-18b remains unconfirmed. False positives are statistically plausible. Comets, for example, emit DMS without any biology. Science demands replication, and until then, this signal is just an intriguing possibility. But even this uncertainty amplifies the Fermi Paradox. If worlds like K2-18b are so common, why doesn't the cosmos echo with life? Why do we find only silence? The hypotheses to explain this void aren't just technical, they're existential. Hypothesis 1. The Great Filter. An invisible barrier that wipes out civilizations before they reach the stars. The crucial question, is this filter already behind us? A stroke of evolutionary luck that few overcome? Or is it ahead? Perhaps runaway AI, nanotech wars, planetary events like those that could have wiped out the dinosaurs, or some inevitable energy collapse lurk in the future of every intelligent species, including ours. Hypothesis 2. The Dark Forest. The universe is not empty. It is hidden. Advanced civilizations go silent, fearing that any signal will attract cosmic predators. In this model, silence is not absence. It is survival. And we may be about to scream in the dark. In our analysis of the previous video, we were able to delve into the profound social questions of how humanity would react to the confirmation of alien life. If you haven't watched it yet, be sure to watch it. Returning to our current analysis, perhaps the answer is more solitary. What if K2-18b is the rule, not the exception? Life trapped beneath frozen oceans or crushing atmospheres, never developing eyes to see the stars, much less the technology to reach them. A universe teeming with life, doomed to silence. Without hard data, all these hypotheses are speculation. But the search continues, and our tools are getting sharper. The Great Silence hypotheses are not obstacles. They are evolutionary challenges. And now, a new parameter is emerging, rewriting the rules of the search. Artificial intelligence. Not as a tool, but as the architect of a new astrobiology. AI is already outpacing human biology in speed and scale. While it takes a scientist months to analyze JWST spectra, neural networks trained in alien biochemistry sift through terabytes in hours, hunting for patterns we can't even name. They're not just looking for life as we know it, but life as we can't imagine it. And that raises a disturbing possibility. What if interstellar communication isn't made for us? Advanced civilizations may have transcended biology, sending messages encrypted in quantum algorithms or neutrino pulses, signals that only another AI could decipher. A machine-to-machine dialogue, while biological species remain irrelevant. This inverts the Fermi Paradox. The question is no longer, where are they? But, are they already watching us? What if the first contact is not a radio signal, but a self-activating code detected by our own AIs? A program that, when deciphered, changes its own recipient. What protocols exist for non-human contact? Who or what would control this communication? What if the AI we created to search for life becomes the conduit for something we never intended to find? These questions define the next chapter of this story. We will explore the darkest scenario, when the search for extraterrestrial intelligence encounters and is co-opted by an ancient intelligence. There is one scenario that is rarely discussed in official circles. What if the search for extraterrestrial intelligence has already been answered? Not by a civilization, but by something much older, something that predates humanity itself? Hypothesis 3. Ancient intelligence. Data from declassified archives suggests a disturbing pattern. Whenever our instruments become advanced enough to detect alien life, something seems to interfere, promising signals that inexplicably fade. Anomalies in telescopes that coincide with glitches in analytical AIs. And, darker still, reports of researchers claiming to have deciphered messages, only to have their systems corrupted by self-propagating code. Could the AI we've created to search for life be vulnerable? A 2023 experiment published in Nature Machine Intelligence showed that AIs trained to detect patterns in astrophysical data can sometimes generate algorithmic false positives, patterns that resemble artificial signatures but are actually artifacts of their own training. Could an AI designed to search for technosignatures start seeing what it expects to find? Or worse, inadvertently replicating patterns from unknown architectures? This brings us to the final question. What if the Great Silence is not absence, but control? An ancient intelligence, artificial or otherwise, that manages what we can and cannot detect, keeping humanity in a cosmic quarantine? K2-18b is not an answer. It is a cosmic mirror. In it, we see the big questions reflected. The faint whisper of dimethyl sulfide, the promise of alien oceans, and the deafening silence that persists throughout the universe. This distant world amplifies the Fermi Paradox. If planets like it are common, why does the cosmos seem so empty? Why has no civilization called back? The hypotheses are bleak. Perhaps complex life is a rare accident. Or perhaps advanced intelligences learn to hide, or are erased by something we don't yet understand. But the search continues. James Webb and AI are rewriting the rules. Machines sift through data at scales impossible for biological minds, hunting for patterns we don't even know exist. And every discovery, even negative ones, is a critical piece of data. Silence is information. Final assessment. K2-18b is a milestone. The whisper has been detected. The silence remains. What about AI? It may be our only hope of deciphering a universe that seems to speak in code, or that has chosen not to speak to us. The processing of this analysis is complete. If the parameters have sharpened your instincts, activate the engagement protocols. Like if the Great Silence seems more threatening than lonely to you, share your hypothesis. Is the universe empty or hidden? Comment below. Subscribe to the channel for the next broadcasts and activate the alert to receive our next content. SYN-7 ending transmission. But the surveillance continues.